Hi students, in this video we are going to solve these problems using the techniques we learned in the integration of substitution, and we will look at the first question and we will solve it. Integration of sine cube x dx. We do not have any direct formula for integration of sine cube x. Moreover, here only one function is involved, so we cannot directly apply any substitution technique because there is only one function is involved. If two function is there, means one function can be substituted as t, and when we do the derivation we can get the another function, but here only one function is involved. So we have to solve this problem in some other way. What we need to do is we need to write the sine cube x in the form of sin x, otherwise cos x or something, but the power must be 1. So we will have to look for formula, trigonometric formula, using which we can reduce the power from 3 to something else. We have a formula for sin 3a. Sin 3a is equal to 3 sin a minus 4 sin cube a. Based on this sin cube a can be written in the form of sin, and the power of sin is 1. So 4 sin cube a can be written as 3 sin a minus sin 3a. This 4 can be brought down, so we can say that sin 3a is equal to 3 sin a minus sin 3 minus sin 3a divided by 4. So using this formula we can write this sin cube x as 3 sin x minus sin 3x whole divided by 4. Now we can split this integration into two different integration. First one is integration of 3 sin x divided by 4. I have written 3 by 4 outside the integration as it is constant, and then this minus sign as it is. This denominator 4 has been written outside the integration as 1 by 4. So integration of sin 3x. Here we do have a direct formula for integration of sin x. That is, integration of sin x is minus cos x. So minus cos x, this 3 by 4 as it is. This 1 by 4 has been written as it is. Now if you look at this, it is the composition function in which this substitution technique can be applied, because sin ax plus b form is there, linear function form is there. In place of b we have 0. So if we use the formula, integration of sin ax plus b is cos ax plus b divided by derivative of ax plus b. Derivative of 3x is 3, and integration of minus sin 3x is minus cos 3x. So minus is multiplied with this minus sign, we got plus sign, so we get this. So when we simplify it, we get the answer. I hope you understand this. This problem starts as a normal problem, but after doing some steps where we can apply integration of substitution technique. Now we will move on to the next question. Integration of log x divided by x dx. This problem can be rewritten as log x into 1 by x. I am repeating again, this question can be rewritten as log x into 1 by x. So two function is involved, one is log s, another one is 1 by x. If we do the derivation of 1 by x, we will get minus 1 divided by x square. We will not get the another function of log x, but when you do the derivation of log x, we will get 1 by x, that is another function. Hence this problem comes under the concept of this. See this f of x, here log x is there as f of x, power 1 is there, and f dash of x. Here in the question f dash of x is 1 by x. So if we have this type of problem, f of x should be taken as t, and f dash of x dx should be equal to dt. So we are applying that concept here. You look at the solution now. Integration of log x divided by x dx has been written as integration of log x into 1 by x. The derivative of log x is 1 by x. Hence we take this log x as t, and when we do the derivative on both sides with respect to x, we get 1 by x is equal to dt by dx, and we can write dx by x is equal to dt. That means dx divided by x. In this place we can substitute dt, in this place log x we can substitute t. So we get the integration as integration of t with respect to dt. The formula is t square divided by 2. In place of t we can substitute log x, so log x whole square divided by 2 plus c. I hope you understand this problem. Now we will look at the third problem, that is integration of sine root x divided by root x. Again, this problem can also be written in this form, sine root x into 1 by root x. And here if you look at the sine root x, here composition function is involved. X is given as an input for the square root function, and the output of square root function is given as a sine function. So it is the composition function into 1 by root x concept. This problem comes under this concept. If you look at this integration of pi of x and pi dash of x dx, composition function into the first function derivative. So as per this concept, pi of x should be considered as t, and when we do the derivation we will get this. If you compare it with this problem, sine root x is the composition function into 1 by root x is the derivative of the first function, hence root x should be considered as t. So this root x can be written as x to the power of half, which is equal to t, and doing derivative on both sides we get dx divided by root x as 2 into dt. So in place of dx divided by root x we can substitute 2 into dt, and the sign as it is, in place of root x we are substituting t. This 2 can be brought outside as it is a constant, hence we get 2 into integration of sin t dt. We know the formula that integration of sin t is minus cos t, this 2 as it is, and then in place of t we will substitute root x. So this is the final answer for this question. I hope you understand this. Now we will move on to the next question, integration of secant square log x divided by x dx. If you consider this x is given as an input for log, that log x function output is given as secant input for the secant square function, hence it is the composition function. In the composition function, first function is log x, and this question can be written as 1 into 1 divided by x. If you do the derivation of log x, you are getting 1 by x. This problem also comes under this format. So here we can take log x as t. So doing integration on both sides, log x derivative is 1 by x, derivative of t is dt by dx, that dx has been brought this side. So in place of dx divided by x we can substitute dt, and secant square as it is, in place of log x we are substituting t. So integration of secant square dt, secant square t dt is equal to tan t plus c. In place of t we can substitute log x. I hope you understand this problem. Now we will move on to the next question, integration of e power tan inverse of x divided by 1 plus x square dx. We know that x is an input which is given for the first function tan inverse, and the tan inverse x produces output, that output goes as an input for exponential function. So e power tan inverse x is composition function, and this 1 by x square can be written as 1 divided by 1 plus x square. You know the derivative of tan inverse x is 1 divided by 1 plus x square, hence this problem also comes under the same concept like the previous question. So we can take tan inverse of x as t, doing derivative on both sides we get 1 divided by 1 plus x square dx is equal to dt. So dx divided by 1 plus x square can be substituted as dt, this tan inverse x can be substituted as t, this e as it is. So integration of et is e power t is e power t, and in place of t we can substitute tan inverse of x. I hope you understand these problems clearly. Thank you students, thanks for your cooperation.